Okay, so in this next video, we're looking at some of the features, the properties of the graphs of quadratic functions. So we're just going to start with this function over here, and I've picked some values of x for us to put in and see what we get as a y value. So remember, we use brackets, -5 squared, x squared plus 6x plus 8. So this is 25 minus 30 plus 8, which gives me 3. So at this point, you might want to pause, test the other values, fill them in here, and then draw a sketch on the grid of this function. All right, so my next one I picked is -4 squared plus 6 times -4 plus 8 is 16 minus 24 plus 8, which is 0. We'll do one more. -3 squared plus 6 times -3 plus 8, which turns out to be -2. So if I fill in the rest, -2 and 0, 3, and 8. So if I plot these points on here, 0, 8 is here, -4, -1 and 3 is here, 2, 0, and -3, -2 here, and then there, and -5 and 3 is there. So here is, our parabola, more or less. And so what we're going to do is identify these features in this table below. So the first thing is the vertex. And the vertex is either a maximum or a minimum. So if I think of this upward facing u, it's that point right there. If I have a downward facing u, it's that point right there. And it is the point where the parabola changes direction. Remember, the parabola is the name of our graph. This type of a graph is called a parabola. Changes direction. So if I look at this one, I can see, for as I go from left to right, that it comes down, reaches its lowest point, and then goes back up like that. So the vertex is this point, -3, -2. So on here, -3, -2. A maximum or minimum. So a minimum occurs when I have an upward facing u. It's the lowest point. So the highest point on this type of parabola is a max, and a min is the lowest point. So in this case, we have a minimum, and it occurs at -2. So the vertex actually informs the minimum or maximum. So that's where I got that from. The axis of symmetry is a line that cuts the parabola into two. Into two sort of mirror images, I guess would be a better way to say that. Mirror images. So in this one, if you imagine this line right here, if I were able to pick up this piece of paper, this piece of grid paper, and fold it along this line, this part here would match up perfectly with this part here, and this point with this point, and so on. And so that's what our axis of symmetry is. It's a line that cuts it in half exactly, where if I folded it, it would line up perfectly. And so that line is right here where x equals -3. So that's also informed by the vertex. So the vertex, the x coordinate, gives me the axis of symmetry. The y coordinate, as I showed here, gives me the minimum or maximum. X-intercepts are the points, could just be one, points where the parabola either touches or crosses the x-axis. So if I look at my image up here, that's this and this. So they are at -4, 0 and -2. So this particular parabola has two x-intercepts. The y-intercept, there will only be one y-intercept, and there's always one y-intercept point where the parabola crosses the y-axis. And that's right here at 8. So 0, 8. Incidentally, in our equation, this value, if it's written in ax squared plus bx plus c, the value here is the y-intercept. So that's that 8 right there. So down here, I have another one for you to try. Y equals 2x squared minus 8. There's our function. Put these values in for x, and then see if you can identify these same features: vertex, max or min, axis of symmetry, x-intercepts, y-intercept, after you make the picture right here for your graph. Okay, so hopefully that you found these values for y. So I hope you found those, and the parabola should look something like this. Oops, get rid of that point. There we go. And then my x-intercepts are -2 and 2. And then I have the point -3, 10, and over here. So this parabola looks something like that. I should find that the vertex was at 0, -8. That's this point right here. This one has a minimum, and the minimum is at -8. The axis of symmetry is the line x equals 0, which is actually just the y-axis right here. That would be the line I could fold this parabola and have it line up perfectly. X-intercepts are there and there. And my y-intercept is down here where the vertex is as well. They overlap in this case. It's the same point. So I hope you were able to find those features for that parabola. And next, we have a parabola that we're going to use the graphing calculator to find some of its points. So if I look at this function, I know already, because of this value of -2, that is my y-intercept. And I could put this into my graphing calculator. So I put y1 equals x squared plus x minus 2, touch graph, and you get the picture of the graph. The other thing you can do is hit second graph, and you get a table. And you could use that data table. So I'm going to look at that and put down a few points to help me draw the graph. So that -1. So I have these points and -3, 4, which is there. So connecting those points like that, you can see that the vertex is here somewhere, but I'm not sure exactly where it is. So one trick that we can do to find out where that is use 2 points that have the same y value. So here, for example, I'm going to use the x-intercepts. So my x-intercepts are at +1 and -2. And so to find the axis of symmetry, I'm just going to find the average of those. So I'm going to go -2 + 1 and divide by 2. So I'm just adding this and dividing it by 2. So -1 over 2 is my answer. It's at -1/2. So that's right here. So my axis of symmetry is x equals -0.5. That's also going to inform the vertex. I know that the vertex is at -0.5, but I don't know the y value yet. So what I'm going to do is in my calculator to find the y value, I'm going to go -0.5 squared. I'm just putting it into here. I'm subbing it in for x plus -0.5 minus 2. And so if I put that in exactly as I see it here, my calculator spits out -2.25. That's the y value of the vertex, so -2.25. That's this point right here. So I can say that's at -0.5, -2.25 is the vertex. So now I found 2 of the features of the parabola. Our other features are the intercepts, which I can get from the table. Here they are. 1, 0, x-intercepts, 1, 0, and -2. The y-intercept, I also have that on the table. That's right here, 0, -2. So that's this point right there. The y-intercept is 0, -2. Remember, that comes from the value of c. That gives me the y-intercept. Okay, and now in this last problem, this is taken from the textbook, and it says some children are playing at a local splash pad, and so you can see in the picture that the water from these jets here is making a parabolic shape like that. It comes out of the nozzle, goes up, reaches its highest point, and then falls back down. So this is a parabola, and it tells us the path of water from one of those jets forms an arch that can be defined by this function. So here's our function, where x represents horizontal distance from the opening. So our x-axis, it says, is horizontal distance. And f of x, which really just means y, remember this is y, is height above the ground. So this is the height in feet. And this horizontal distance is also in feet. So what I'm going to do is put this equation into my calculator. So I'm going to touch y equals, and y1 is going to be -0.12 x squared plus 3x. And then I'm going to graph that. And the problem with my graph is that I'm only going to see kind of this much of it, and the rest of it's kind of cut off. So I need to be able to see the rest of it, or I know that it goes actually higher up. Sorry, it goes a bit higher up and comes down, something like that. So what we need to do is change the window of the calculator. So touch the button that says window, and you can see on the window that there's an x max, an x min, something that says x scale, and then there's the version for y as well, y max, y min, y scale. So we can leave the scales at 1. We can leave the minimums at -10. But what we want to see is higher up and farther over. So let's change those those maximums. So I'm going to make the x max 30, and I'm going to make the y max also 30. And then I'm going to touch graph again. So we're going to change the window to these 30, 30, and then touch graph again. And when I do that, then I should be able to see this parabola. My screen ends kind of here and up here somewhere. Okay, so now I'm seeing the whole thing. And so that's a really important skill, is to be able to play with the window and be able to obtain the entire graph. And now I'm going to get the calculator to find some of the features for me. So the first thing I want to do is find the maximum. So if I'm using the Texas Instruments calculator, the TI calculator, what I need to do is hit second and then trace, which is one of the buttons along the top. So I hit second and then trace. And then I get a menu of things that I can find on a function. And the one that I'm looking for here is, let's say, this point, the maximum. We want to find the maximum. So I hit maximum. And then there's a little cursor, right? It looks like this. So what I want to do is, after I hit maximum, the calculator says right bound, and there's a question mark. So what I want to do first is move it onto the maximum here, and then move it to the right side, hit enter, and then it says left bound, and I want to move it to the left, so I use the arrows to move it to the left, hit enter, and then it says guess, and you want to hit enter again. And then it should tell me at the bottom of the screen, x equals 12.5 and y equals 18.75. So hopefully you got those. If not, you can have a look at that in class, but that's how I find the maximum. So what does that tell me? What is the maximum height of the arch of water? Well, the height is the y-axis. So this is the maximum height. And how far from the opening can it reach? So how far does the water go? Okay, I want to find this point over there. So that point over there, I'm going to look for something else. So I'm going to hit again, second, trace, and this time I'm going to pick the option that says 0. And I'm going to do this left bound, right bound business again. So you want to move your cursor to this point here, then move it, and now I'm forgetting if the order is right or left first, but you'll see when you do it. You want to move it to the left and then to the right. It says guess, you hit enter again, and it should tell me that that point is 25. It'll say x equals 25, y equals 0. So that's telling me where that point is right here. That's the x-intercept, right? That's where the water hits the ground for this particular one. So you want to try a couple of these questions where it gives you a function like this, and you put it into your calculator, and you're looking for things like the maximum or minimum. You're looking for where are the zeros.